All right, hey guys. So we're here doing lesson one. Um, so for my seventh graders today, what we're going to be doing is we're going to be clicking through these slides and we're going to review today's lesson. Today's lesson, we're going to be distinguishing the difference between physical and chemical changes in matter. So for physical changes are normally shown through a change in shape, state, or size. For an example, that's like cutting paper or chopping wood. One thing that many people get confused on is a physical change can also be water freezing, that is changing state, okay? But it is still water. So water freezes and it turns to ice, or water evaporates and it turns into water vapor. It is still water, so it is a physical change. For chemical changes, to be able to know if a chemical change has occurred, it's unexpected color change, unexpected odor, bubbles or gas, temperature change, formation of a precipitate. An example would be adding two clear liquids and a new color is produced. One thing that helps me understand chemical changes is remembering this saying. It's please excuse my coughs, sneezes, and burps. So please excuse my coughs, sneezes, and burps. Okay? So for P, that would be the precipitate. The E would be an energy forming. The C would be color change. The S would be sound. Okay, so there's a loud bang or a firework goes off and you hear that explosion. And the B is bubbles or gas. Okay, so please excuse my coughs, sneezes, and burps. Energy that would be coming off would be heat, light, color change would be an unexpected color change, okay? When it's unexpected. So if I have two clear liquids and a new color is produced, it's not an unexpected color change if I take red Kool-Aid powder and mix it into water. That's expected. If it was red Kool-Aid powder and mixed into water, that would be a physical change. Okay? The Kool-Aid, the sugar going into the water would be a physical change. The unexpected color change would be like in a firework. Yes, it says, oh, this firework's supposed to be red, but that is an unexpected color change because it exploded. And that mineral that's inside of that firework had a chemical change to make this color happen. All right, so what you're gonna do here is you're gonna click on this video and you're gonna watch this video about chemical and physical changes. On a sheet of paper or on a Google Doc, write down 5 facts from the video. What some of you guys have already been doing and have already started on when you've been going through this lesson is you've been sending me a Google Doc, and that way I can comment on it and tell you where you went wrong. You don't have to, but if you would like to, you may do so. I'm going to click on the video and I'm going to have it show here in this video. If you would like to click on it on your own, you may do so and then fast forward through it. But I'm going to go ahead and click on that video now.
too. But you know what I love even more? S'mores. I brought chocolate and graham crackers so we can make some.
Yeah, RJ. Hey, what's up? Something wrong?
These crackers are all broken into pieces. Look.
No worries. It's just a physical change.
What do you mean physical change?
Physical change is just when the size, shape, or state of matter changes. See, the cracker is broken, so its shape is different, but the pieces are still graham crackers. We can use them.
Yeah, I know. It just stinks that they broke. I don't know how it happened.
Well, physical changes like this happen a few different ways. Motion, pressure, or even temperature could have made the crackers break.
I guess I was a little rough with my backpack when they were in there. Maybe I shouldn't have thrown it around.
Probably not. Throwing the crackers around is probably exactly why they're broken now. But as small as the pieces are, they are still graham crackers, and their molecules haven't changed.
Well, there's no way I could change their molecules. How would I do that?
There are ways. When the molecules of matter change, it's called a chemical change. Chemical changes usually can't be reversed like physical changes can. When the molecules change, the matter turns into something totally different, like the logs in our fire.
But the logs are still logs.
They are, but not for long. The extreme heat of the fire is causing a chemical change that turns the logs from wood to ash.
Huh. Yeah, I see some ash at the bottom of the fire. I guess I didn't realize it used to be the logs. How can you tell that it's a chemical change?
There are clues. If gas forms, if light or heat appears when the change takes place, or something changes colors. You know, like when you see a penny that looks green, or rust at the bottom of an old car.
Oh, yeah, I've seen that. So I guess it's good that I didn't drop the box of crackers in the fire, huh?
That would have meant no s'mores for us. If the crackers had been burned, we wouldn't have been able to turn them back into crackers. We probably wouldn't even be able to tell they were crackers to begin with. So really, broken crackers? Not so bad.
And burnt crackers? No good.
You got it.
Okay, I think I understand the difference between a physical and chemical change now. Breaking the crackers was just a physical change because only the form of the crackers was changed. Temperature, pressure, or motion, like me throwing my bag around, can cause physical change. A chemical change changes the molecules in matter, and that can't usually be reversed. A physical change can be reversed most of the time.
Nice job.
I'm just going to pretend I understood that and say thank you.
All right, so you have your 5 facts from that video written down. So we're going to move on to activity 1. Activity 1, you're going to click through the presentation link. You're going to create a T-chart on a sheet of paper. A T-chart looks like this. On one side of the T-chart, you're going to write chemical. And on the other side, you're going to write physical. You're going to determine whether each slide is demonstrating a chemical or a physical change. All right, so we've got our chemical and physical changes throughout the year. Here, in January, when you see fireworks burning in the sky, what type of change is it? What evidence do you have? Remember, our types of evidence, our precipitate, our energy, which is sound, heat, light, our color change, our unexpected color change. The S, sound. And B, which is bubbles or gas. Which one would it be for the fireworks? Here in February, when Martin Luther King's memorial was chiseled out of stone, what kind of change was it? What evidence do you have? Chemical or physical? March, what kind of change occurs when the sand gets moved around to create this sandcastle? How do you know? Chemical or physical? What's happening here? Is anything new being created? April, Texas bluebonnets. In the month of April, we are in the season of spring. Rainfall, sunlight, and CO2 help the growth of the Texas bluebonnets. What is it called? What kind of change happens here? What evidence do you have? Remember when we talked about photosynthesis? And we said water, sunlight, and carbon dioxide went into the plant, and out of the plant came glucose, which is sugar, and oxygen. What is happening here? Was anything new created? Is this a physical or chemical change? Cinco de Mayo. Some friends gathered to make nachos for their Cinco de Mayo celebration. What change did the nacho chips go through to create the dish? What evidence do you have? Physical or chemical? June. During June, we have the most direct sunlight. This causes the water in our pools to evaporate. What kind of change occurs here? Justify your answer. Remember when I said if something changes state from solid, liquid, or gas? If it changes state, but it is the same substance, does a chemical change occur? Or is it physical? Fourth of July, the Statue of Liberty was made of copper. Over time, it has turned a greenish blue color. What type of change is this? What evidence do you have? August. In August, school starts up again. A school bus is polluting the streets of Houston with smog. This smog indicates what type of change. What evidence do we have? What do you notice going on here? What's happening here? What evidence is going on here in this picture? Hurricane season in September. Hurricanes hit Galveston and Houston in September of 2008. It uprooted and broke many trees. What kind of change is this? Justify your answer. Jack-o'-lanterns in October. To make a jack-o'-lantern, a physical change and chemical change occurs. Explain how this is possible in your evidence. Remember what happens in a physical change and a chemical change. Thanksgiving, November. A turkey is baked for a Thanksgiving lunch. What type of change does the turkey go through? What evidence do we have? Remember that turkeys don't look like this before they go in. What happens to the color of the skin? What happens to the texture of the turkey? Can we eat raw turkey? What happens if we eat raw turkey? Why do we have to cook it? And finally, in Christmas in December, when this puppy unwraps his Christmas gift, what type of change will the wrapping paper go through? Justify your answer. Activity 2, you're going to click through the presentation attached to this link. You're going to create a Venn diagram on a sheet of paper. You're going to label one side chemical and the other side physical. You're going to determine if each side is a chemical or physical change. If you think it can be both, put it in the middle and write an explanation. A Venn diagram, remember, looks like this. On one side, we have chemical. On the other side, we have physical. What is this part? This is what we call both. if you think it's chemical and physical. That's this section here. All right, here we have our apple being cut. Is it just a physical change or is there a chemical change? Here we've got our saliva and our food. Remember when we talked about chemical digestion? And physical digestion. Chemical digestion occurs with our saliva and in our stomach. Physical digestion occurs, well, in our stomach with our stomach acid. Physical digestion occurs when our teeth break down the food, when our stomach churns and breaks down the food. So remember that when we had chemical digestion and physical digestion, we're talking about their changes. There are types of changes occurring. Vinegar and baking soda. How many of you guys have created a volcano at home, a paper mache volcano, and you poured together vinegar and baking soda, and these bubbles, these bubbles or gas was formed? That tells us that a chemical change has occurred. Not a physical change, a chemical change. How many of you guys have put Mentos into Coke? How many of you guys have put Mentos into Coke and it exploded and all those bubbles were created? That was that gas being released. But right here, we're not talking about putting Mentos into Coke. We're talking about smashing Mentos. If Mentos are just being smashed, are they still Mentos? Not a chemical change, it's a physical change. Leaves changing color in the fall. Leaves changing color in the fall is not a physical change. They're changing color. They change color because the chemical makeup of the leaves are changing. So if the molecules in the leaves change, then a new substance is formed, which gives us a chemical change. Fireworks exploding. This is one of the easiest chemical changes to determine. Why? Oh, goodness me. Why? Because there's a color change. There's a sound. There's heat, light. There's a gas being formed. How many of you guys have smelled like fireworks after the 4th of July? When apples rot, they change color. They also smell bad. Their texture also changes. They're mushy. So this is not a physical change. It is a chemical change. Squeezing lemons. If you squeeze a lemon and the lemon juice comes out, is it still lemon? Yes, it is just a physical change. Mixing oil and water. How many of you guys have taken salad dressing and had to shake it before you put it on your salad? That's because it is oil and another liquid in there. When you mix them together, it's just a physical change. Nothing else new is being created. Blushing. When your cheeks turn red, is that a chemical change? It's not, because it is just your blood rushing to your cheeks. It is not a chemical change. That is an expected, listen again, it's expected color change. It is not an unexpected color change. Nothing new is being created. Chewing your food. Think about your chemical and physical digestion. If we're only talking about chewing the food, that is a physical change. The production of intestinal gas. I'm pretty sure none of you have put something in your mouth that tastes like your intestinal gas or smells like your intestinal gas. So something new was created there to smell like that. If it's a new smell, that tells us that it is a chemical change. All right, in activity 3, around your home, perform the following actions if you have the materials and determine if it is a physical or chemical change. If you do not have the materials, think about what type of changes occur. Breaking an egg, scrambling an egg, cooking an egg, snapping a match in half, mixing water and food coloring in a water bottle, mixing 1 tablespoon of baking soda and 1/4 cup of vinegar in a bowl. If any of you guys would like to do this or these experiments at home and you have these materials, don't go out and buy any, stay home, be safe. But if you have any of these materials at home and you want to do these and record yourself doing them and post them to me, I can post them onto my YouTube channel or Twitter if you give me permission. If not, you can still email it to me and send me the video if you would like me to see it. But that is the end of lesson 1. If you have any questions, be sure to reach out and ask me. If you have anything else that you want to do, if you come up with other experiments and want to record those, you can do that as well. If you want to sorry, I lost my train of thought. Go ahead and subscribe to my YouTube channel if you want. That way that you can get notifications whenever I post a new video, so you can stay up to date on your lessons. I don't want you to fall behind. I will send this one out in an email so that you can have the link to this one. But after all that, it seems like we're done, and have a good rest of your day. All right, see you guys later. Bye.